Hi, my name is Graydon Cortez, and this is my video lab report for Lab 1, Constant Velocity. To begin with, the purpose of this lab is to observe the motion of an object that is moving at the same speed without changing direction and compare it to a computational model based on physics principles. The main physics principle used in this lab is Newton's second law, also known as the momentum principle, which says that a net force changes the momentum of an object where the momentum is the product of mass and velocity. In conjunction with Newton's second law, two important equations need to be taken into consideration. Velocity final equals velocity initial plus F net over m times delta t, and position final equals position initial plus velocity of x times delta t. Knowing this, the main result of this lab will be to prove that an object moving will have a constant velocity if the net force on it is zero. This will be proven via the tracker software and GlowScript code. Moreover, this lab will prove the momentum principle is true and that the following formula can be used in different settings. F net equals delta P divided by delta T. Before beginning the experiment, it is important to note the initial conditions that were present. The system used is the inside of a toilet paper roll without any sheets of paper. The surroundings that interacted with the system is a half-moon-shaped table in a dorm room. Lastly, at t equals 0, the initial position of the toilet paper was 0.00100 meters. The initial velocity was negative 1.06900 meters per second, and the mass of the toilet paper roll is approximately 0.014 kilograms. For the experiment, the toilet paper was pushed over a flat surface and videotape was taken of it, rolling at constant velocity. This was done via the tracker software, and as you can see to the right, the times and positions of the object in motion were recorded based off of the technical inputs in the video put into tracker. For the coding, there were a couple steps to create a computational model to get a position versus time data set. The following were what was done. First, total time needs to be divided into small time steps. Then at each time step, you need to compute the force, update the velocity using a velocity update formula, update the position using the position update formula, and update the time. These formulas are illustrated in the right in the code, updated from the lab starter code, and the position versus time data is also shown on the right. When comparing the results of the visual and computational data, it becomes apparent that Newton's second law holds true in this scenario. Both the data and model positions had relatively the same position versus time graph based on the scatter plots to the right, and the true mass of the object and the approximated mass of the object did not impact the results. The only difference that should be noted is that sometimes the computational data deviated from the observed data, so the data might not have been observed in perfect conditions. So where could the experiment possibly have gone wrong? First off, the toilet paper roll is not a perfect cylinder, so it rolls in an odd way which could have impacted the velocity result observed. Secondly, the friction of the table is not considered in this experiment, but is important in reality, so the tracker results could have been slightly off from the computational ones because of this. Lastly, the original video recorded for tracker was longer than the clip version, and the velocity could have potentially fallen off later in the video, which could negatively impact the comparison results. Overall, Newton's second law was proven via the resulting data sets, but what if conditions were different? If the axis chosen at the beginning of the experiment were flipped, two things would change. The velocity, since it is a vector based on direction, and the position graph would have been flipped. Otherwise, everything else would have remained the same. Lastly, since we knew that F net was 0 newtons, we can assume, knowing the surrounding, that four forces are acting on the toilet paper roll in the scenario. Gravity, the desk pushing back against gravity, the force used to initially push the toilet paper roll, and the friction of the desk pushing against that initial push. These forces are balanced, resulting in F net being equal to 0 and making our assumptions have some validity. Thank you for listening.